Welcome to the deep dive. You know that feeling, right? Drowning in info, just wanting the core stuff without getting totally bogged down.
Yeah.
We're here to cut through that.
Today, we're diving deep into something, well, really foundational for modern software. Often overlooked, though. Configuration management in microservices. And we're looking specifically at how Spring Boot handles it. Okay, let's unpack this.
Absolutely. And our mission today really is to demystify how these little building blocks here, microservices, actually get their marching orders.
Right.
We'll show you why this isn't just some tech detail. It's crucial for reliability, security, scalability, all the good stuff.
Yeah.
And you'll see how Spring Boot, based on sources like a really solid Spring Boot guide on config, makes it surprisingly approachable, even if you're kind of new to this whole microservices game.
Okay, let's start right there then. Configuration management in microservices.
Yeah.
What exactly is that, like fundamentally?
Well, at its heart, it's all about giving the right instructions, the right settings to each individual microservice.
Think of each service like a specialized tool in a workshop. It needs specific info to work properly.
Like what?
Things like, where's the database it needs to talk to? Which network port should it listen on? Or maybe an API key for some external service it uses.
Gotcha.
Configuration management is just the system you use to get those settings, those parameters to the service.
And why is getting this right so critical? I mean, I can imagine things going pretty wrong if you mess this up.
Oh, absolutely. You definitely want to avoid the pain. Imagine this. You build a service, works great on your laptop.
Yep. Classic scenario.
Then you push it to testing and boom, it falls over. Why? Because it's still trying to hit your local database.
Oh.
Or worse, you deploy to production and a tiny typo in, say, a connection string takes down something important.
Ouch.
Configuration management stops that kind of thing.
Oh.
Make sure services get the right settings for where they're running, dev, test, prod, whatever. And crucially, without hard coding them.
Right. Hard coding sounds bad.
It's a huge security risk, and it makes updates a total nightmare. This whole process is about avoiding those manual, risky steps.
Okay, so avoiding disaster is one thing. But what are the positive reasons? The real benefits for, the developers, the architects listening?
Oh, the benefits are huge. First up, flexibility. Big time. You can update a database address, tweak logging, switch an API endpoint.
Without changing the code.
Exactly. Without touching the code, without even restarting the service. That's massive for moving fast.
Wow, okay.
Then there's consistency, making sure every instance of your service, no matter how many you spin up, uses the exact same correct settings. That prevents weird, inconsistent bugs. Scalability, too. When you need more instances or new services, they just grab their config and go. It supports those dynamic cloud environments.
Makes sense.
And, like we touched on, security. Seriously, hard coding a password in your code, just don't. Configuration management gives you ways to keep secrets safe and separate.
It's definitely sounding essential. So if we want to really get this, what are the core ideas, the big concepts behind managing all this configuration stuff?
Yeah, we can break it down into a few key principles. First, externalized configuration. This is fundamental. Your settings live outside your actual application code.
Separate files or?
Files, environment variables, a dedicated server. The point is they're separate. That separation gives you agility.
Okay.
Then, ideally, you want centralized management. Imagine one place, one source of truth for all config across all your services. Makes life so much easier to maintain.
I can see that.
We also need environment-specific settings. Your dev setup needs different instructions than your production setup, right? Test database versus real database.
Definitely.
Security, obviously, is always there, protecting passwords, keys, anything sensitive, encryption, access control, all that.
Right.
And the really cool one, dynamic updates. The ability for a running service to notice a config change and apply it without needing a restart, that's powerful for uptime.
Okay, that lays out the what and why really well. Now, let's bring in Spring Boot. It's super popular for Java microservices. How does it make this whole configuration thing easier, especially for beginners?
Spring Boot's magic is really in its convention over configuration approach. It just makes things feel intuitive. It gives you several ways to externalize those settings pretty easily.
Like how?
Well, the most common starting point is using simple configuration files. You've probably seen application.properties or application.aml files right in your project.
Yeah, those look familiar.
Perfect for things like setting the server port, maybe basic database URLs. Easy to manage.
Okay.
But for sensitive stuff, passwords, API keys, you absolutely don't want those in your code repository. So you use environment variables, you set them on the server or container where the app runs.
Keeps them separate and secure.
Exactly. And then for quick overrides, maybe during development or troubleshooting, you can use command line options when you launch the app. And the beauty is, with all these methods, you can change settings, point to a different database, adjust a timeout without rebuilding your code. No redeploy needed sometimes.
That does sound way simpler. You mentioned different environments earlier, dev, test, prod. That always feels like a place you could easily trip up. How does Spring Boot help manage that specifically?
Yeah, that's where Spring Boot's profiles feature is brilliant. It's like having different lenses for your application.
Profiles. How does that work?
You can create separate config files named like application-def.properties or application-prod.eml.
Okay, so one for each environment.
Precisely. Inside application dev, you put your development database connection, maybe enable more logging. In application prod, you put the real production data details, maybe different API keys.
And how does the app know which one to use?
When you start your application, you just tell Spring Boot which profile to activate, say, dev or prod. It then automatically loads the main application.properties and the specific profile file, with the profile settings overriding the defaults if needed.
Ah, clever. So it just picks up the right settings seamlessly.
Exactly. Connects to the test database in dev, the production one in prod. It solves that common problem really elegantly.
Okay, that works great for one or maybe a few services, but let's scale up. What happens when you're dealing with, I don't know, dozens, maybe hundreds of microservices? Managing all those individual files sounds like a nightmare.
You're absolutely right. That's where individual files just don't scale. And that's exactly the problem that Spring Cloud Config solves.
Spring Cloud Config. Okay, what's the idea there?
Think of it as a central library, or maybe a hub, just for configurations. Instead of each service having its own files, you put all the configurations for all your services in one central place.
Where? Like another database.
Often it's backed by a Git repository, which is great for versioning and auditing changes, but it could be other things too.
Okay, so a central Git repo holds all the settings.
Right. Then, when one of your microservices starts up, its first job is to call out to the Spring Cloud Config server. It says, hey, I'm the user service running in the production profile. Give me my settings.
And the server sends them back.
Exactly. It finds the right properties for that service and profile in the central repo and sends them over. The huge win here is centralized control.
Ah, so change it once in the repo.
And potentially all the services that use that setting can pick it up. Much, much easier than updating files scattered everywhere. And remember, dynamic updates. Spring Cloud Config supports that too, letting services refresh their config without restarting.
That sounds powerful for the Spring ecosystem. But what if you're not just using Spring Boot? Or you're in a really large mixed environment? Are there other tools people use?
Oh, definitely. Spring Cloud Config is great, but it's not the only game in town. The wider microservices world has other popular options.
Like what?
Well, there's Console from HashiCorp. It's often called a service mesh tool, but it does service discovery and distributed configuration. It's like a phone book and settings manager rolled into one.
Okay, console. What else?
If you're deploying your services using Kubernetes, which is super common now,
Yeah, Kubernetes is everywhere.
then Kubernetes itself has built-in ways to handle this. You use config maps for regular, non-sensitive configuration data.
Config maps, got it.
And for the sensitive stuff, passwords, tokens, keys, you use Kubernetes secrets. They're specifically designed to hold confidential information securely within the cluster.
So Kubernetes has its own native solutions.
It does. And then for really serious, dedicated secret management, there's Vault, also from HashiCorp.
Vault.
Yeah, Vault is purpose-built just for securely storing and tightly controlling access to secrets. Think API keys, database credentials, certificates. It integrates with lots of systems, including Spring Boot apps.
So lots of options depending on your stack and needs.
Exactly. The key is knowing these tools exist as you scale up.
Let's circle back to security for a moment because it keeps coming up. We're talking passwords, API keys, really sensitive stuff in these configurations. How does Spring Boot specifically help keep that data safe?
Spring Boot really pushes you towards good security practices here. First, it actually supports encrypting sensitive properties right within your application.properties file if you absolutely must store them there, though that's less common now.
Encrypting them. Okay.
But more importantly, it makes it easy to not put them there in the first place. It has excellent integration support for tools like Vault or using platform things like Kubernetes secrets.
So it plays nice with the dedicated secret managers.
Exactly. The main principle it encourages is get sensitive data out of your codebase, out of your step config files, use environment variables, use Vault, use secrets, externalize and secure it. That drastically cuts down your risk if, say, your code repo gets compromised.
Never hard code secrets. Seems like rule number 1.
Absolutely. Rule number 0, maybe?
Okay, so for someone just starting out with Spring Boot and microservices, wanting to do this right from the beginning, what are the key takeaways? The actionable best practices from the source guide.
Right. The guide gives some really practical steps for beginners. First, start simple. Don't immediately jump to Spring Cloud config if you only have 1 or 2 services. Use the basic application.properties or IML files first. Get comfortable.
Makes sense. Don't overcomplicate.
Second, use profiles. Seriously, use them right away. Application-dev.properties, application-prod.properties. Keep those environments separate. It prevents so many headaches.
Non-negotiable, basically.
Pretty much. Third, and we keep saying it, keep sensitive data safe. No hard-coded passwords. Use environment variables as a starting point or look into proper secret management tools early on.
Got it. Environment variables minimum.
Fourth, centralize when ready. Once you find yourself managing config for, say, 5, 10, or more services, then start looking at Spring Cloud config or similar solutions. Don't do it on day 1 if you don't need it.
Scale into it.
Exactly. And finally, maybe the most crucial advice for any change. Test your changes. Always, always test configuration changes in a dev or staging environment before they go anywhere near production. A typo in config can be just as bad as a bug in code.
Solid advice. Test, test, test. Even with these best practices, though, where do people still tend to run into trouble? What are the common gotchas with configuration management?
Yeah, even with good tools, there are definitely pitfalls. The sources point out a few recurring ones. A big one is just inconsistency. Different instances of the same service somehow ending up with slightly different configurations leads to really weird, hard-to-track bugs.
Yeah, that sounds painful.
Another is the sheer complexity as you grow. Just keeping track of what setting affects which service across potentially hundreds of services can become overwhelming without strong tooling and process.
Information overload.
Totally. And then there's the operational challenge, updating without downtime. If changing a setting requires restarting a service, that impacts your users. Minimizing or eliminating that is key.
Okay, so inconsistency, complexity, and downtime during updates. What are the direct solutions the source points to for tackling those?
Well, for inconsistency and complexity, the clear answer is using a centralized configuration hub, something like Spring Cloud Config Console or Kubernetes Config Maps. A single source of truth tames the chaos.
Centralized to simplify.
Exactly. For the downtime issue during updates, the solution is dynamic updates. Leveraging features like Spring Boot's refresh scope, or capabilities in tools like Console or Spring Cloud Config let services pick up changes without restarting.
The refresh capability.
And finally, to combat those errors caused by inconsistencies or typos, it comes back to testing. Rigorous testing of configuration changes in pre-production environments is your best defense against letting mistakes slip through.
Test again. Makes perfect sense. All right, that brings us nicely to the end of this deep dive. What we've really seen today is that configuration management isn't just some minor detail. It's fundamental. It's about how you organize and secure the instructions that make all those microservices actually work together reliably.
Precisely. We saw how you can start simply with Spring Boot's built-in files and profiles, which is great for getting going.
Yeah, very approachable.
But then, as you scale, you have powerful options like Spring Cloud Config or platform tools like Kubernetes Config Maps and Secrets to manage things centrally and securely. The whole point is keeping settings external, keeping them safe, and making them easy to update. That's how you build systems that are both reliable and flexible.
Yeah, that flexibility seems key.
It really is. So, maybe the final thought to leave you with is this. Think about that flow of configuration. It's like the nervous system of your distributed application, right?
Interesting analogy.
So how does truly mastering that flow, ensuring those signals get delivered correctly and securely, become just as vital as writing the actual code itself when you're aiming to build software that's genuinely resilient, adaptable, and ready for whatever comes next.